Okay, guys, so today we're going to talk about how you can prove triangles are similar. So there are technically three different ways that we can prove triangles are similar, but we're going to only focus on two of them. We're going to focus on angle-angle similarity and side-side-side similarity. Remember that when we talked about similar figures, we know that angles are congruent. And so what we'll be looking for angle-angle similarity is we're going to be looking for two pairs of angles that are congruent. So angle A is congruent to angle D, so that's one pair of angles. Angle B is congruent to angle E, so that's a second pair of angles. So I could say triangle ABC is similar to triangle DEC by angle-angle similarity. The other thing we talked about with similar figures is that sides are proportional. It means that they've been multiplied by the same scale factor to go from the pre-image to the image. So when we do side-side-side similarity, what we're looking for is three pairs of sides that are all proportional to each other. So AB and DE, so if I do AB divided by DE, that has to be equal to BC divided by EF, which has to be equal to AC divided by DF. So all of these reduce to the same scale factor. You do need to check all three sides because we have to see that it is side, side, and side. So what we're going to do is look at some examples below and determine if they are similar by one of these properties, whether it's by angle-angle similarity or if it's by side-side-side similarity. The only time you can do side-side-side similarity is if you know all three sets of sides for both triangles. So if we look at example 1, we want to determine, are the triangles similar? So we'll say yes or no. It says if so if it says yes, we're going to write the similarity statement and name the theorem that was used. So the similarity statement is where we'll say triangle is similar to triangle. And the theorem used is either angle-angle similarity or side-side-side similarity. So the first thing I notice on number 1 is that we're given sides. We are told that MN has a length of 26, ML has a length of 26, and that NL has a length of 30. We're also told that OQ has a length of 13, PQ has a length of 13, and that OP has a length of 15. So because we're given sides, we should check side, side, side. So I need to see, and I need to be consistent. So I'm going to do the left triangle divided by the right triangle. So 26 divided by 13 needs to be equal to 26 divided by 13, needs to be equal to 30 divided by 15. So when I do that, I get 2 over 1 equals 2 over 1 equals 2 over 1. So those are all equal, so that checks out. So I can say triangle MNL is similar to triangle QPO by angle-angle similarity. Not angle-angle, that was silly. That was side-side-side. Ha ha ha. Side, side, side. Because we just looked at all the sides. Okay, cool. So now we're going to look at number 2. On number 2, I see these little arrows. Remember that the arrows mean parallel. So I remember back from Unit 3 that we have if parallel lines, then we know alternate interior angles are congruent. So if I go from my parallel line down one of the two transversals to another parallel side, I get that the angles inside of that are congruent. So angle A is congruent to angle D, because if lines are parallel, then alternate interior angles are congruent. The other thing I see is that BC and AD intersect at point E, creating a bow tie together. We know by the vertical angles theorem that vertical angles are congruent. So that's a second pair of angles. Angle AEB is congruent to angle DEC by the vertical angles theorem. So we can say triangle ABE is similar to triangle DCE by angle-angle similarity. Okay, so for number 3, I see a 52-degree angle and a 52-degree angle, but I don't know the other angles. So angle-angle similarity is out because we don't know enough angles. I also don't know the length of any sides. So side-side-side similarity is out. So since neither of the methods, the theorems that we talked about, work, these are not similar. And we probably should have a yes here because I said yes or no. Are they similar? Yes. Yes, they are. So the rest of these are about applying that proportionality of the sides to be able to find different measures. So for number 4, it says a 1.4 meter tall child is standing next to a flagpole. The child's shadow is 1.2 meters long. At the same time, the shadow of the flagpole is 5.7 meters long. How tall is the flagpole? So, whenever we're working with shadows, shadows are on the ground. They're always going to be the bottom of whatever triangle we draw. We're talking about a shadow so a shadow is formed by when a light source, like the sun, hits something. So we're going to have a little person, a child, and then that child's shadow is going to be on the ground. The child's height and the shadow will be perpendicular to each other, so we're going to create those as right triangles. The angle that is right here will be congruent to the angle that will happen for the flagpole, because when the sun hits the shadow for the flagpole, it will create that same angle. Next trimester in Unit 9, we'll talk about how this angle that I just marked, the acute angle that's not the right angle, is called an angle of elevation because it's elevating up to look to the sun. So now that I've got my 2 right triangles, I can now start labeling things. So the child is 1.4 meters tall. And the child's shadow is 1.2 meters long. So shadows always go on the ground. It says that at the same time, the shadow of the flagpole is 7.5 meters long. So flagpole shadow. We want to know how tall the flagpole is. So this is my X. So what we're going to do is put similar measurements in the same spot in our fractions. I like to do height over height equals shadow over shadow. That's my personal preference. So I'm going to take the height of the person, the child, divided by the height of the flag, just because I like to go left divided by right. So 1.4 divided by X equals. And then I'm going to set up another proportion. I'm going to use the shadows now. So since I did the child divided by the flag, I need the child's shadow, which is 1.2, divided by the flag's shadow, which is 7.5. So now I have a proportion where I have 2 fractions equal to each other. So all I need to do is cross multiply. 1 times 1.2x times x is 1.2x equals, and then I'm going to have to do 1.4 times 7.5. So 1.4 times 7.5 is 10.5. And then I'm going to divide both sides by 1.2. And I get that the flagpole is 8.75 meters tall. Okay, so for these last ones, it's really important to pay attention to the two triangles in the picture. And so there's always going to be a smaller triangle. So I've got the smaller purple triangle here, this smaller purple triangle here, and this smaller purple triangle here. Okay. Then there's a larger triangle that contains that one. So this yellow triangle actually contains the purple one. And so what I'm going to do is I'm going to actually copy this. We're going to actually copy it. Okay. So there's my x. Okay. So I'm going to now erase this guy. And I'm going to pretend that this doesn't exist anymore and this doesn't exist anymore because I'm just focused on this triangle up here. Okay, so now focused on the yellow triangle, I need to know how long this whole side is. Because this first chunk is 11 and the second chunk is 3x, I'm going to make that whole side 3x plus 11. So then on the other one, I'm going to do the same thing. I have x plus 2 plus 4. 2 plus 4 is 6. So I'm going to make this side x plus 6. So now, when I set this up, I'm going to take a measurement from the triangle on the left. So I'm going to use the 4, divided by that corresponding side in the larger yellow triangle, which is this whole thing, which is the x plus 6. I'm then going to set that equal to, and then go back to the original triangle and grab the 11 because I haven't used that yet. And then I'm going to divide that by the corresponding side in the largest triangle, which is the 3x plus 11. So now I have a proportion, and so all I need to do is cross multiply. So I'm going to have 11 times x plus 6 equals, and then I'm going to have 4 times 3x plus 11. I'm going to distribute 11x, 66, distribute again, 12x, and 44. I'm then going to subtract 11x from both sides and get 66 equals x plus 44. And then subtract 44 from both sides and get that x is 22. So I think things like number 4 are a little bit more confusing for that purpose. But number 5 makes it is a little bit more obvious when we do this one. So I've got that purple triangle. What I'm going to actually do this time is I think I'm just going to copy this top part. We're just going to focus on that. Copy, paste. Okay. So I am currently ignoring these little segments because they're not part of that triangle. Cool. Okay. So then I've got that larger yellow triangle. So this would be the whole side there, and this would be this whole side here, and there's that side. So this chunk right here to the left is x. This chunk here on the right is 5, So to get their total, it's x plus 5. I don't need to do anything with this because that's not part of this larger triangle. And then this whole side's 36 already. So for this one, I'm going to take the triangle on the left. So I'm going to use this 36 first. I'm going to divide that by x minus 3. And then set that equal to, and then go back to the triangle with the 36, so the x plus 5. And then that's going to be divided by 5. So we're going to get to distribute on this one. So let's cross multiply. 36 times 5 is 180. And then on our other, we're going to have x minus 3 times x plus 5. I'm going to distribute that x to the x in the plus 5. So x times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. I need to combine my like terms on the right-hand side. So 5x minus 3x is positive 2x minus 15. I then need to subtract 180 from both sides so that everything is on the same side and my equation is equal to 0. So at this point, I'm not going to give you something that doesn't factor, so we need to factor this. You can use the quadratic formula. Just make sure you only include the positive value when you are done for x. So I need two numbers that multiply to be negative 195, but add to be positive 2. So if it's a negative number that we're multiplying to be, I need one positive number and one negative number. I notice that 195 ends in a 5. So I'm going to try dividing it by things that are divisible by 5 and see which of them has that difference of 2. So 195 divided by 5 is 39. So 39 times negative 5 would give me negative 195. But when I add 39 and negative 5, I get positive 34, which is not the same thing as positive 2. So I know that's not going to be a good option because that's the difference is too big. I noticed that 39 is divisible by 3. So the next thing I kind of want to try is 3 times 5, which is 15. So I'm going to try 195 divided by 15, which is 13. And if I do positive 15 times negative 13, I get negative 195. If I add 15 and negative 13, I get positive 2. So this is my set of two numbers. So I'm going to take those and put x plus 15 and x minus 13 in parentheses. To finish solving this, I now need to take each of these factors and set them equal to 0 and see which of them gives me a positive number. Because this distance right here is x, and x has to be a positive value in order to represent distance, how long something is. And so when I solve for 15, the x plus 15, I get x is negative 15. And since it's negative, that doesn't make sense because distance can't be negative. However, when I do x minus 13 equals 0, when I add 13 to both sides, I get x is 13. So this is the positive solution, so this is our answer. And that would be called the root, because that's where this quadratic equation would cross the x-axis when x is 13. Okay, so this last one is just like that. So let's see if not writing it out as two separate triangles is going to work. So I'm going to do a side divided by the corresponding side. So small triangle 4 divided by that long side in the larger one, so x plus 4. And then we'll set that equal to, going back to the small triangle, I've got x plus 4. And then that corresponds to the 9. So now I can cross multiply. 4 times 9 is 36. And then I'm going to have x plus 4 times x plus 4. I'm going to distribute. 36 equals x squared plus 4x. 4 times x is 4x. 4 times 4 is 16. I then need to combine like terms. 36 equals x squared plus 8x plus 16. I now need to have this equation equal to 0 since I still have an x squared term. So I'm going to subtract 36. So I get 0 equals x squared plus 8x minus 20, because 16 minus 36 is negative 20. So now I'm to the point where I need to figure out what is two numbers that multiply to be negative 20, but add to be 8. So numbers that multiply to be 20, I've got 1 times 20, 2 times 10, 4 times 5. One of these needs to be negative, so I'm going to try these ones being negative. Negative 1 plus 20 is 19, so that one's not going to work. Negative 2 plus 10 is 8. Ooh, that one works. And then that would be 1 for the last one, so that wouldn't work. So we'll take the number negative 2 and 10, and we'll split that out into x minus 2 and x plus 10. And then finally, we set each of these factors equal to 0, and we see which of them gives us our positive number for x. So when I add 2 to both sides, I get x is 2. That's our positive value. This is our answer. When I subtract 10 from both sides, I get x is negative 10. And I can't have a negative, so this is not the answer. So what I need you guys to do is complete your practice for today. Hopefully I'll be back tomorrow, and then you guys can talk about that then.